about another important aspect of the series, of power series. Let's talk about Taylor's series. You know, when we started this power series, we talk about the power series itself. There we just said the series will be expressed in terms of the powers of the x. That is, f of x will be expressed in terms of the power of x as a plus bx plus cx squared plus dx cubed. Now, we talk about somebody who simplified it, Maclaurin. Fx will now be all these coefficients. Maclaurin had helped us to get them, work them out. And he said A will be F0. B will be differential. X multiplied by differential, first differential. C will be second differential, 0. Where you put in 0 over 2 factorial. Third differential over 2 factorial. Plus, like that. You can see. Now, we are not saying that, okay, fine. If we can get x, f of x, a certain place, we know the value of fx. We will be able to find fx plus delta x. We can describe it as this again. Fx. You can describe it as f0 plus x. You can see. And you can see that this place is f0. You see? Plus x, f of 0. You can see. Because the reference point is 0. Now, this is how the curve will look like. When we make 0 our reference point, this is 0. So the curve has the value there, and then look like this. So this is x. This is fx. So at this point, let's say this is y. That's what it will be like. That's what it will be like. Now let us now see. This is what Taylor did. Like, okay, fine. If we know f, the value of f at a point, and f is now increased, what will we be able to use this series to find the value of fx plus delta x or minus delta x? Let's look at how it will be now. Now this is 0 point. Now let us make the reference point a behind. So from here to here now, let's call this a. So if this is the reference point now, this is the reference point, and this value now they say that it's not changing. If we are starting it from here, and let's say this is a, from here to here, let's call it h. You can see. So if we follow this now, we can now say that f a plus h. Please, from here to this place. You can see f a plus h is now going to give me f a plus h. You can see plus a square. Can you see? If we follow this, plus h cube plus, you can see. That's what it will be like. So this is Taylor's series. So let me write it out for greater use. So let's say we know fx, like this point now. So fx plus h is now going to give us fx plus, you know, like this. X has replaced this a now. H is the increment plus h into f x, that is the first differential, plus x squared into f x over 2 factorial plus, like that. You can see. So this is the Taylor's series. And you can see everything follows the same pattern. Power series, Maclaurin series, and Taylor series. I'd advise that you write it somewhere. But once you have known this one is easy to memorize. Now let's look at one example. Now let's calmly work this out. It says express sign x plus h as a series of the powers of x of h. X sine x plus h as a series of the power of h and evaluate sine 44 degrees correct to 5 decimal places. You know, when we have sine x, we want to express it in powers of x. Powers of x, please. Here we use Maclaurin. But when we are now having something like sine x plus or minus h, I'm trying to make the distinction. This one will be expressed in the powers of h. Please take note. In the powers of h. And in this place, we use Taylor series. You know, Maclaurin reworked the power series or simplified the power series. That is why we are having it. And from there, we are able to get this. Now, let's really go into the answering of the question. Now, let's look at what it is like. So, we have this sine x plus h. Okay, let me write like this. Fx plus h. The first one is going to give us fx plus h. Fx plus h squared. Fx plus h cubed. Fx over 3 factorial plus, and it goes on like that. Now, we have to express sine x plus h as a series of the powers of h. Now, we know this to be sine x plus h. So, let's look at what's fx. Okay, fx, you know what fx is. The next one is going to be so fx. In this place, sine x is equal to fx. Sine x is equal to fx from this reference. Therefore, cos x is equal to what derivative of fx? We have minus sine x to the second derivative. Minus cos x, the third derivative. Let me come to this side. So, sine x is the fourth. Cos x. I believe this should be enough. So, from here we can now say that sine x plus h is going to be sine x plus h cos x minus h squared sine x over 2 factorial minus h cubed cos x over 3 factorial plus h raised to the power 4 sine x over 4 factorial plus h raised to the power 5 cos x over 5 factorial plus. So that's the expression for sine x plus h. And you know, we said it before under differentiation that the angles are expressed in radians when we are talking about this, or when we are differentiating. Angles are expressed in rads. Now let's go to the second part of the question. It says that we should express sine x plus h. Sine 44. Now we should now evaluate sine 44. Sine 44. You know, we don't have standard figure for sine 44, so we are going to use the closest one to it, which is sine 45. So we are going to write as sine 45 minus 1. And then, let's express everything in radians. So this is going to be sine pi over 4 minus pi over 180. Looking at the Taylor series now, you can easily conclude that x is pi over 4, while h is minus 180 minus pi over 180 rad. So let's put it here. You can now say that sine 44 is equal to sine minus pi over 180 cos pi over 4. Cos pi over 4, sorry. Minus pi over 180 all squared minus. So that's going to still give me minus pi over 180 all squared sin pi over 4 times 1 over 2 factorial. So this is this one, sin 2 factorial. Now let's go to the third one. Minus 180 pi over 180, that's going to give me positive, plus pi over 180 all cube, minus in 3 places is going to give me minus, and this minus again makes it positive, cos x, that is cos pi over 4, multiplied by 1 over 3 factorial. Let's do the next one. Pi minus pi over 180 raised to power 4 is going to give me positive pi over 180 raised to power 4. Plus again, that's giving me positive. So it's going to give me plus pi over 180 all raised to power 4 sin pi over 4 times 1 over 4 factorial. I think from there I can stop. Now, let us now put in the values inside the equation. We know what sin pi over 4 is. We know what pi over 180 is. And when we use our calculator, we will get the answer. So the answer is approximately 0.6946537, and we are told to 5 decimal places. So it's going to be 0.69466 to 5 decimal places. So this is how to use Taylor's series. It is about increment or decrease from one point known to another point, that is the value. How the value varies when there is little increment or decrease in the value of x. That's when we use the Taylor series. But when we want to express fx like cos x, sin x in the powers of x, that's where we use Maclaurin and power series generally. So this is everything about Taylor series. I promise you I still do some exercises under this topic to clarify it. Until then, let's look into other uses of the series, and we look into some standard series. Let's look into some standard series, and from there, you'll be able to look into how to put all these series to use.